All right. So without further ado, everybody, welcome to a Microsoft vFunction and Optica webinar. We're going to be introducing you to a wonderful partner vFunction who's going to present how their AI can help transform your monolithic applications. Um, I'll take you through the agenda. It's kind of simple. I'll do a quick introduction into Optica, who we are. Then I'll pass it over to Billy Bernhardt from Microsoft, who's kind enough to join us. He's the National Intelligent Cloud Manager for Canada and representing Microsoft in this meeting. And then finally, we'll hand it over to Shatanik Bhattarji from vFunction. He's a modernization architect, and we'll be spending most of our time with Shatanik doing the demo. So before we begin, so who are we? We are a consulting firm founded in 2009. We are partners of both Microsoft and vFunction. We don't have that many partners. We're very careful in who we choose because we want to make big commitments to them. And our focus at Optica is identifying AI and automation solutions to help us deliver better modernization results. And the three characteristics we look for are stronger results, quicker time frames at lower costs, and vFunction hits those very, very well. And you'll see they're able to modernize applications with much greater success rate than if you're trying to do it manually in much shorter time frames and at a lower cost. A little bit more about us. We serve both Canada and the US. Our customers include Bell, BMO, Lotto Quebec, Verizon, Delta, and American Express. So thank you for joining us. We hope the next 40 minutes approximately will be time well spent. So Billy, I'll pass it on to you. Do you have anything to present? Or are you just going to be talking?
Nope, just a quick introduction. That's all from my side. So like Ivan mentioned, I am one of the national intelligent cloud managers for our small medium corporate space at Microsoft. I've got a couple other partners, Laura Stone and Jamie Wakeham, who are my partners in crime in Canada. But I have responsibility over our application development kind of service area within the Canadian market. And so thank you for all of you that took your time to join us today. I know you could be spending your time doing a bunch of other things, and so you chose to spend it with us, and so we greatly appreciate that. As Ivan mentioned, Optica has been a really great partner with us. They're really dedicated to the Microsoft space and helping our customers innovate faster. Really been great on the application and infrastructure modernization space. And like you mentioned, they've partnered with vFunction to really help those customers modernize faster with less costs, better performance, less time, and overall just better efficiency using this AI tooling to help look at applications and figure out how we can modernize them now and for the future. And so really looking forward to the session that we have for today and really how we can help organizations innovate faster going forward. And so with that, I will pass it over to Shatanik.
Okay, sure. Thank you, Billy. So Shatanik, I'm now making you the presenter. Hopefully you will receive that.
Yep, I do. And do you see my screen?
We do.
Great. All right. Hi, everyone. I'm Shatanik. As Ivan mentioned, I'm a modernization architect at vFunction. In the interest of time, let me just jump right into it here. All right. So I'm going to start by defining the problem that we're trying to solve here. The State of CIO survey last year told us that apparently the top 3 priorities for CIOs within organizations is modernizing applications. It is only kind of the higher priorities are security and just improving the infrastructure in general. A survey that we commissioned with Wakefield was this modernization effort. Like, what is the landscape here? So apparently 79% of the modernization efforts fail. The average cost dedicated to modernization is 1.5 million, and the average timeline is 16 months. What this means is that people think about modernization, they kind of underestimate their time, money, resources that they dedicate to this project. And then, at an average of 16 months, they kind of pull the plug from a particular project with not much to show. And we were like, okay, so what does this mean? Like, why is this happening? So if you think about it, typically when you have a monolith, you keep adding features to it over time. And if you say change even one line of code, typically what that entails is you need to write unit tests, need to write system tests, integration tests, end-to-end tests, so on and so forth. And all this results in a burgeoning regression suite. So now what this means is that for every feature that you need to implement, the test cycle gets longer, the release cycle gets longer, and therefore the incoming number of business requirements that need to be implemented in your application, the throughput of that implementation throughput gets lower over periods of time. And therefore, since this application over a period of time gets complex, it gets hard to ramp up developers because of maybe the older tech stack, because of many features that are entangled within each other, whatever might be the case. The other thing is that, again, when you're looking to scale some functionality within the monolith, typically you have to deploy multiple instances of that monolith, and you don't have like focused scalability. You have to scale the entire monolith. And sometimes features are not written in a way that they can be just simply vertically scaled. And all this basically leads to decreased innovation. Essentially, this thing unable to meet business requirements. The number of requirements getting implemented in these applications is lower over a period of time, and therefore organizations start losing their competitive edge. So that is like really why people want to modernize. One of the, I'm just going to highlight this one. It got a lot of bad press earlier this year. Basically, Southwest scheduling system, they needed to modernize it. They kept kicking the can down the road, which kind of led to like a catastrophe earlier this year. They got a lot of bad press. And yeah, the rest is not going to harp too much on this. All right, so when thinking about modernization strategies, typically what people do is that they want to first just get quick benefits of moving to the cloud. So applications basically get rehosted, replatformed. You do some containerization of the monolith, or you're looking to move out of licensed stack. Like for example, maybe you have some kind of application server that you're paying licenses for, or some database, some relational database that you're paying licenses for. So you can just get like the open source equivalents of them in the cloud and just deploy there. That is replatforming. However, for hyperscalers like, for example, Azure, there are a lot of these services that are available on the cloud. And for your application to get full benefit of those services, you need to make it cloud native. You want to decompose it into smaller pieces, microservices, mini services, whatever might be the case. That is where the right side of this graph lies. And then once you've decomposed it into some kind of distributed architecture, you want to monitor the services deployed and ensure that these services then in the future don't become individual monoliths. Essentially, you don't want a service to grow way too much in functionality. In the future, you want to track it just so that if need be, you might need to split these services into smaller pieces. All right, so this is a quick Dilbert here. I'm assuming some of you or all of you have gone through this. I have at least gone through this where, we were told that, modernize. What does that mean? Containerize. And then, okay, what is containers going to solve for us? No one knows. And then just throw tech terms like Kubernetes or some kind of container orchestration framework, but it is not really solving the problem of scalability. All right, now this part is our controversial take here. Currently, when you're looking to decompose a monolith, I believe, or we believe, it is done in the wrong way. Today's methodology, that is that application SMEs, architects, analysts, they kind of get together in a room. They figure out the domain design of the application, and they construct an architecture of the application should have been doing already. However, this does not take into account how the application is written today. Typically, there's this frustration that, okay, I am done with how the application works now. I don't care for it. I just want to rewrite it from scratch. One thing that the application does, the good thing about an existing monolith is that it works. It has tested features in it. It is large. It might be annoying to deal with it, but it does run. And in general, when you're trying to decompose into domains, like, people come up with an idea of what the surface layer of every service needs to be. They start data modeling up front. Then basically the REST endpoints on top, the data model at the bottom. Then they fill in the business logic after the fact, after they've done all this design. And these like menial tasks, like splitting out code from an existing monolith, containerizing, figuring out the right configuration files, all that kind of takes precedence over actually decomposing the application into domain-based services. So given this problem, here comes vFunction. This is the problem we identified in the market. And vFunction is now a platform which basically profiles your running application. And based on that, it does some bottom-up design. And it gives you an interactive platform where an architect or a developer or any SME, application SME, can basically reconcile their enterprise domain knowledge with the bottom-up analysis that vFunction does. And using an intelligent metric-based approach, you can split or you can create an architecture that is the least risky, essentially. Because sometimes what happens is that when you rewrite things from scratch, there's loss in feature parity, for example. There's loss in feature parity, and also there is a problem of doing, when you do things from scratch, you're rethinking of how the application is supposed to work. However, when you do it with vFunction, basically this analysis process gets accelerated by a lot. Then there are things like automating the tedious dev tasks, like copying relevant source code out of your monolith into the shape of a service, minimizing configuration files, that code that might exist in the context of a service, like figuring out what that is, then deleting that from source projects. All these like tedious dev tasks kind of also get vFunction helps a lot with these things. And once you've done one application with this, you can essentially use these concepts to do this across the board, across your application estate, and create a repeatable factory model. There's some numbers on the right, as I mentioned, acceleration, cost reduction. Since there is acceleration, therefore there is cost reduction. But really, to me, the main thing is this risk reduction. Having gone through a manual modernization project myself prior to joining vFunction, it's really when you think about what it means to decompose an application, a lot of considerations get lost. Like what should be shared across services, what should be a common library across services, what functionality is important, what is not important. These things kind of get highlighted in vFunction, and that leads to some risk reduction here. So in my opinion, the risk reduction is like the main factor that kind of drives, that is provided by vFunction. Right. Yeah, these are just some companies who have used vFunction and have allowed us to use their names. So vFunction basically has two main portions in the platform. One is the assessment hub, which is a decision-making tool. Essentially, if you have lots of applications, you can run assessment hub or static analysis of the binaries of your application and create these assessment reports. And using those reports, you can basically prioritize which applications you want to modernize first. And then there's the flagship product, which is the Modernization Hub. Essentially, for the chosen applications, you can do runtime analysis on them. And this is the interactive vFunction Studio UI that I mentioned earlier. That basically, this is where you create the microservices architecture. All right, so the typical life cycle of modernization. is first you go through a planning phase. You Again, if you have, say, a large estate, suppose you have 5,000 applications, and which typically banks, automotive companies, they just have like 5,000, 10,000. We've been given these numbers. They have these number of applications. Before even getting into modernization, typically they know what they want to refactor, or they want to just simply migrate to the cloud as is. After you've decided that, you can use some, for example, for Azure, you can use Azure Migrate. You can simply rehost or replatform your existing application. And then basically deploy that to some target environment like AKS, Azure, Spring Apps, etc. Then for the remaining applications, you can run this assessment hub. And assessment hub, what it does is it calculates an important metric for all of your applications, that is architectural technical debt. This is different from typical sonar cubes or code quality tools, code smells. We're more calculating architectural technical smells, I guess, in a manner of speaking. Based on this architectural technical debt, you can, given a high technical debt and then business value, you can deprioritize, or you can choose that, say the architectural technical debt is high and the business value is low. You don't want to refactor it. You could just want to lift and shift it. However, if the architectural technical debt is low, business value is high, you might want to refactor it into microservices. Business value is high and architectural technical debt is high, or architectural technical debt is low. For those cases, you want to proceed with decomposing the application. After you've chosen, again, these applications from the assessment hub, for the selected applications, you run dynamic learning. So the static analysis from assessment hub supplements or complements the dynamic learning in this phase here. Both of them together, they give you an initial starting point reference architecture that is, given your application the way it runs, vFunction will initially give you a simplified architecture that prioritizes ease of extraction. Because, as you might already know in your experience working in the IT industry, an MVP distributed architecture is way more important than the perfect architecture. So vFunction will basically give you that starting point that this is the easiest route to extraction. And on the Studio UI piece here, this is where a user interacts with the architecture, merges, reconciles their top-down domain knowledge with the vFunction analysis, creates some services, distributed architecture. And from there, you can extract services and make it target environment ready and deploy to a target environment. After you've done this, right, so there's a vFunction continuous modernization manager, which is essentially whatever architecture you created in the modernization hub, it will monitor that architecture and ensure it will basically alert you on some key metrics, which I will show you later, and ensure that you have your architecture in check. It is not becoming a bunch of distributed monoliths, essentially. This is the use case. There's lots of things you can do on vFunction, but I'll give you an example of Trend Micro here. We worked with them, and so Trend Micro is a cybersecurity company. They had a security product on the cloud. It was a huge application. They didn't even go for a full-on like this microservices architecture. They simply broke the application into 4 services, 4 mini services. And just by doing that, they reduced their cloud spend by 50%. And essentially, you can like scale functionality that needs to be scaled together. You don't need to scale all of it together. And just not a fancy microservices architecture, just by decomposing into four smaller chunks with the right visibility and feedback from vFunction, they were able to reduce their cloud spend. All right, fine. So now let me move on to the fun stuff here, which is the actual demo. All right. Just a sec. Yeah, there it is. Okay. So by default, when you've installed vFunction, you get a dashboard like this. This is an executive summary of modernization status across your application estates. For example, in this test environment, I have 262 apps, and there's a summary of how many are in each phase of modernization. 67 learning, 115 in analysis phase, 3 service creation, and so on and so forth. As I was saying, there is an assessment hub, which basically gives you this view here, this eye of Sauron kind of view, where all the applications, you simply run a static analysis on them. And you don't really need to install an agent for that. When you install the vFunction server, you get a CLI tool. With that CLI tool, you run a command against a folder which has binaries for applications. And that generates a JSON file, which can then get imported into the vFunction server to create this view for you. You can basically, filter on this page here. You can change what you see here. You can change by the application size, so on and so forth. So I will show you what the report actually looks like. So if I were to choose this, so this number here is the key metric for assessment. 68% architectural technical debt, as I mentioned earlier. This first tab here helps you just visualize what this means for you. So for example, for this application, for every dollar spent, 32 cents are actually going towards innovation and 68 cents are going towards maintaining this technical debt, out of which 3 cents are going towards maintaining the top 10 worst offenders. If I click on the red portion of the donut, I see what they are in descending order of offense. Another way to think about it are these multipliers here. Say you wanted to invest $10,000 for innovation. To get that $10,000 worth of value, you would need to spend $31,000. Whereas if you just took care of the top 10 classes, that would become $29,000. But these are just numbers. The point here is no one is looking to get rid of their top 10 classes. You just want to get rid of as many high debt classes as possible, and essentially bring this multiplier as close to 1 as possible. So I've been saying architectural technical debt a bunch. What does it mean? If you think of your application as a graph of classes and resources, the complexity is basically the quality of this graph, or how entangled the elements of this graph are with each other. Risk is the length of this complexity. That is, if you want to implement some feature, how likely are you to touch some unintended part of the code? And that is basically the aggregate metric that takes risk, complexity, and some other factors into play to give you one index to look at. There are some other benefits, like it will look at the aging frameworks and tell you how many what percentage is aging, what percentage is modern. You can set a threshold here to basically give you an alert. When this threshold gets crossed, you will get an email alert that, okay, this is happening in our application. And finally, there's a history tab here, which essentially gives you this technical debt over time. You can integrate the static analysis agent into your CI/CD pipeline. Every time a binary gets built, the static agent gets invoked, and it will calculate the technical debt and show it to you in a graph format. The bottom half is not that important now. This kind of comes from the dynamic analysis. If the static analysis is not enough, you can do dynamic learning on the application. That will give you this refactoring effort. But I will explain this more in detail in the Modernization Hub. All right. And then, there is also typically when executives are making decisions, they don't like to get access to different tools. So you can download what I just showed in PDF format, and you can compare a bunch of PDFs and get into a decision-making session as to what you want to prioritize first. All right, so let's get to the fun part here, which is all right. So when you've decided to do dynamic learning on an application, you install this dynamic agent into your on your running application. So I'll just talk about Java for now, but everything I'm going to say here applies to .NET as well. So I have a demo OMS application. It's an ordering management system. I installed a Java agent on running application. And initially, this black sphere is going to be empty. As the Java agent starts profiling the JVM's heap memory, it basically sends that data to the vFunction server, which runs the algorithm in the backend constantly. And you see that it is recommending 9 services. These numbers basically start growing. 9 services here, 92 method invocations were seen, 79 resources were seen. What all this results in is basically this architecture here. What we see on the screen is basically that starting point architecture. Spheres are services. Size difference between spheres represent relative size difference of services in terms of number of classes. These dotted arrows represent method calls between services. The black sphere is basically the monolith or whatever remains in the monolith. So all the arrows coming out of the black sphere would basically represent the public interface of your application. One thing to note here, for example, there are some inter-service calls. These calls would not get exposed as public, or you can choose to expose it. I'm saying that vFunction is showing you that there are inter-service calls, and these are not the public API for you. They are more a service depends on some other core service, which is the base layer for other services to use. So just taking a step back for a second, if you remember that domain design architecture, just the existence of this, typically learning takes like 2 to 3 days, up to a week, maybe, depending on your application usage. You can learn on a production environment. You can learn on a pre-production environment. You can merge measurements from both these environments. If you have periodic jobs like weekly, monthly, annual tasks, you can run them in QA, merge that into production, so on and so forth. Just the existence of this initial starting point architecture greatly accelerates the event storming session that people go through generally in organizations. All right. One thing I have deliberately not mentioned till now is this color scheme. There is a color scheme of these spheres. This represents exclusivity. Red, blue, green represents low, medium, high levels of exclusivity. What is exclusivity? Why is it important? Why is it highlighted on the screen here? If you think about your monolith, it basically owns 100% of its classes and resources. When you're looking to decompose the monolith, one or more classes and resources would not be a good fit to be discretely a part of one service only. And the sharing of this class is a thing that you want to look at and make a decision on. Essentially, you can either put this shared class in a common library that becomes a compile time dependency for all your services. You can refactor the class into smaller partial classes with corresponding functionality in each service. You can make a class exclusive to one service only. These are key decision points that generally get missed when you're doing this top-level domain-driven design. And these decision points kind of help you accelerate the refinement of services from an existing monolith. Since it is important, this metric has been highlighted here by means of this color scheme. And also there is an overall resource exclusivity, class exclusivity of your architecture. And I will show you as well, like when you select a service here, these metrics are highlighted as well. It is important to review what is non-exclusive and make a decision around it so that you have the appropriate architectural split. By the way, just one thing to note here, when I selected this service, some solid lines get highlighted here. These solid lines represent, as I'm hovering over them, you see that some resources are getting shown at the bottom. This service, modify fulfillment controller, and this order controller, they share tables, read-only tables, read-write tables, and files. vFunction basically tracks these different kinds of resources here: beans, synchronization objects, transaction objects, tables, file sockets, embedded files, etc., etc. So these are the resources that basically get tracked, and they also contribute to this exclusivity metric. Sometimes it's not, you want a theoretical split of your services. However, some tables or some transactions make it so that two or more domains might need to get merged. Again, just to have that MVP of distributed architecture that can get extracted, vFunction will group these things together, and then it's your choice. You can further split the services, you can merge services, but you have that insight, you have that visibility by virtue of tracking transactions and tables. I'm going to show you this. Let me just talk through some concepts here. So this is a service, modified fulfillment. Let me just rename it real quick. The names of the services, if a lot of the entry points to a service are from a class, the name of the class becomes the service name, or there's some common string across method names, then that becomes the name of the service. So it was a modified fulfillment controller in this application. By the way, actually, I skipped over this. So since it's a demo OMS application, it has typical domains for a retail application like ordering, fulfillment, shipping, payment, emailing, etc. And it is important to know these things because the users of vFunction are typically domain experts. They know these things, and they come here to kind of refine the architecture to something that matches with their enterprise domains. So given that, yeah, so there's two entry points in this service. These reviewing the entry points basically gives you an idea of the functionality encapsulated in the service. For example, this modify fulfillment controller dot modify shipping to store pickup and modify store pickup to shipping. And I can look at the call tree here and familiarize myself with the functionality here. Now here you see that this is the entry point. I can go hover over some other method and then make that an entry point. So I can either replace the current entry point, add a new entry point to the current service, add an entry point to some other service, so on and so forth. Again, the flexibility is unlimited here. You can create as many services as possible. You can change the surface area of your service, whatever seems appropriate. Okay, so these are the entry points make the surface layer and the functionality of the service. Dynamic classes. This service has 4 dynamic classes. These are the classes seen by the runtime agent in the JVM, essentially. And these form the business boundaries of your service because this basically shows you how methods are invoked in your running application. However, there are 16 static classes. So it is their runtime classes plus their corresponding compile time dependencies that might not get loaded in the JVM. For example, abstract classes, enumerations, interfaces. The point of having the static analysis is so that you have a full-bodied service, not just like a rough skeleton of what the service needs to be, but a compilable service. That's why we have static classes as well. And finally, there's resources. Again, all the resources that are being used by this service. So now it's decision-making time. As I said, exclusivity is a metric you want to keep track of to make decisions. So this service has 4 classes with 50% exclusivity. If I view these classes, 2 of them are exclusive, this modify fulfillment controller and this corresponding service. 2 are non-exclusive. Let me just look at one of them, shipping service, for example. It's a class here. These methods are used by this particular service. I can click on details. I see that modify fulfillment is using it and shipping price controller is using it. Now, given that this class name is shipping service, maybe I want all shipping related functionality to be encapsulated in the shipping price controller. What can I do about this? I can go to the call tree here. I see that modifier fulfillment service dot get shipping amount is natively calling shipping service dot fetch shipping charges. So instead of doing this, I want this particular service to make an API call to shipping price controller to access this function. So I can click on make entry point and I will add it to shipping price controller. And the moment I do that, the analysis is going to rerun. right? It's going to rerun in the background. It's going to calculate all the metrics for all these services again, verify that the endpoints make sense, the exclusivity is correct, and give me a new, there's a new dotted arrow between this modify fulfillment controller and shipping price controller. So boom, new API. All right, so let me show you another kind of thing that you can do. For example, if I were to look at resources, let me go to non-exclusive resources, all types. I see that these tables are non-exclusive. So for example, let me take this order line table. I see that it's a read-write, there's read-write table access to this order line table from multiple services. All right, so again, it's one of those things. I want modify fulfillment controller to, instead of directly accessing this table, I want it to make an API call to order controller to access this table. So I will simply click on this method call here, go to skip to included class, make this an entry point into my order controller, and this should make my order controller order line table access exclusive in the order controller only. And now you see there's another API call between, oh, this is the shipping controller. All right, so this is the order controller. Modify fulfillment is making an API call to order controller to access that table. Okay, there's more things you can do here, but I'll just show you one more thing. So for example, I have this payment service and Dyna's payment service. For whatever reason, this is where the organizational knowledge comes into play. I can choose to, I want these services to scale together at all points of time. I want one team to maintain all my payment services. I might choose to replace my payment service with some payment gateway, some vendor payment gateway in the future. So I can simply drag and drop one over the other, and that will merge these two services. And again, recalculate the metrics for it, verify that the API layer of these merged services makes sense. All right, so on and so forth. There's lots of things you can do here. You can basically see the history of all the actions taken. There is a powerful resources report because, excuse me, notice that I'm not really, we are not recommending a new data model for the decomposed database. We're not profiling the database. However, we are looking at calls to the database from the application. And once you have settled on some kind of target architecture, you can choose to then refactor the database by getting some insights here. Just one thing to note here is that you don't want to start with modernizing the database first. It is very risky. Say you were to move from, say, Oracle to Postgres, or from Postgres to some NoSQL database, or whatever might be the case. Once you've made the move, if there's a mistake in that data modeling based on some testing or some production upgrades, it is really hard to go back to your previous database. So data migration is a big deal. It is a risky step. It's just best to break down your business logic first, gain insights from your target architecture, and then break the database down. And you can do so by looking at this resources report. I can, excuse me, I can look at the non-exclusive services. I see that, for example, line charge is getting used by these two services. Similarly, there's another view. I can see all the, given a service, what all resources it's using. I can select a bunch of resources here and do the same. By default, people are interested in the database, but you can also do this for your beans and transactions, et cetera, et cetera. All right. So okay, I'm running late here. So let me so suppose I'm happy with this service. I can save this service. It gets ready for extraction here, and I can download the service. What this does is it downloads JSON files which serve as the recipe for your service. So there's an order controller JSON. There's a common library JSON. Common library, whatever is part of the compile time, common library as part of the compile time dependency for order controller. And then there's a YAML file, which is your open API spec for order controller or Swagger. And you also get a code copy tool with vFunction that helps you generate the source code, or not generate, create a source project based on the recipe files from your monolithic source code. So real quick, let me just show you what it is here. So I have this. This is my monolithic source code, OMS Web MVC. And I've copied this code copy and the JSON and YAML that I just downloaded here. So let me show you what it looks like actually. Okay, code copy help. It has a man page here. So I want to create a source file for a source project for my common library. So simply spec source OMS Web MVC, and destination would be just some directory I create here. Done. New source, and I'm going to do the same for the order controller. Spec order controller source and dest order controller. All right, so same thing happens, and just to show you that this actually works. So Maven clean install. The moment I do this, this will build a project. All right, and just to show you what this would in fact look like. So now I have a common project with my typical Java structure, source main Java with classes here. Similarly for order controllers, source main Java, and like controller, order controller repo. So in this package, I have this, so on and so forth. So you have a starter project here. Now the point here is that this is a starter project. Depending on the complexity of the application, you might need to work on some compilation issues, like maybe the data source needs to change. Maybe you need to bring in some interfaces that are not seen in the binaries, maybe, or some enumeration. Enumerations typically get optimized out of compiled binaries, so you might need to copy those over. But you have your business logic with corresponding dependencies in place here. And after this, you're off to the races. You might want to add retry logic. You want basically that circuit breaker pattern. You want to add some service mesh. If you want to do any of that, you have the starter code from your monolith, and then you can go for upgrades after this. Yeah, that's about it. This is basically the life cycle for modernizing applications. And yeah, you do this across the board. Thank you. Thank you. That's all I have for now. There's way more to talk about, but this is not the appropriate forum for this. Thank you.
Thank you very much, Titanic. That was very good. So we've come to the end of the presentation. Does anybody have any questions? I've opened it up to Q&A if you do. You can read. So I got a question from Mike Meir. How long does it take the analysis tool to run and get an accurate picture of the environment?
Yeah, so this is I'll give you my experience here. If you deploy it in production, 1 to 2 days is good, because most critical functionality in the application gets called within those 1 to 2 days. If you have some periodic tasks like monthly or annual reports, maybe you want to do that in QA and just like merge that into a production learning. So long story short, I would say maximum of a week worth of learning to get full insight into your application.
And that time limitation really isn't the application on your side issue. It's you need to have those business processes run through simulation, right? That's what you're getting at.
Exactly.
Yeah.
It has nothing to do with vFunction. It's basically seeing as many paths in the application as possible, whatever that time takes.
Yeah. So to Mike, who asked the question, if you have robust test scripts, pardon me, and you can run them efficiently, vFunction should give you that analysis rather quickly. It's hours and days at that point. If you can run those, like we said, a thorough representation of your workflows. I hope that answers your question. Does anybody else have any questions at this point? Okay, so before we say goodbye to everyone, a couple of things. We'll follow up with you and give you a link if you are interested in doing an assessment. It's a free assessment. You can get an idea of what vFunction can decipher for you in terms of technical debt and so forth. So we'll give you a link to how to sign up for that if you're interested. If not, by all means, feel free to send us the questions. I want to thank all of you for joining us. Shatanik, I want to thank you very much for taking your time to present, and also for Billy from Microsoft for joining us and participating in this. Microsoft's a very important partner of ours, and hopefully we can bring this to some of the Microsoft customers so that they can modernize some difficult applications in a quicker time frame than they thought possible for less money too. So thank you everybody for this. Greatly appreciate it that you joined us, and hope it was productive. Bye-bye,
All right.
everyone.
Thank you, everybody.
Thank you. Thanks, everyone. Bye.
Yeah.